Hello guys, welcome back to my YouTube channel. I hope you all are doing well. Today we are going to learn the chapter square and square roots for class 8 CBSE mathematics. So let's start. So first of all, let us learn what are squares. So while hearing square, what comes in your mind? Uh, the thing that comes in your mind is, according to me, is equal, because square is a shape that has all the sides equal. But this square is a little bit different from this square. In this square, it means the square of a number is the product of the number with the number itself. So can you guess a little bit? So let me say you. For example, 2 into 2. 4 into 4. So when you multiply a number with the number itself, the product you get is called to be the square of that number. For example, 2 into 2 is equal to 4. 4 into 4 is equal to 16. So like this, 4 is equal to the square of 2 and 6 is equal to the square of 4. So now you know what is a square. So now let us learn what is a perfect square. So, now you got a little bit idea of what a square is. So, perfect square means when an exponent of a natural number is 2, the number so obtained is called a square number or a perfect square. Thus, when a number is multiplied by itself, the product is perfect square. For example, 2 is a natural number and it has the exponent 2. 4 is a natural number and it has the exponent 2. 8 is a natural number but it also has exponent 2. So the meaning of the question is that you should not multiply 2 into 2, 4 into 2, 8 into 2. Understood? You should find 2 into 2, 4 into 4. You should multiply the number by itself. Okay, so 2 into 2 is equal to 4. 4 into 4 is equal to 16. Like that, this numbers that get the number that we are obtaining are called perfect squares. They are said to be perfect squares. They can also be called as um, square numbers. Okay, so now you got a little idea of what are perfect square as well. So now let us see how to find a how to find whether a natural number is a perfect square or not. So this is a very easy concept. It is certainly a very easy concept. So here what you should do is find the LCM of that particularly given number. For example, if that number is 441. So first of all we should find the LCM of 441, and 441 comes in 3's table as 147. After 147 it comes in 49's table. 349 is equal to 147, and then 49 comes in 7's table as 7 sevens are and 7 ones are. So in this concept you get to know that you get four numbers. Now you should pair that numbers equally, means 2. In one group there should be two numbers. You should pair the numbers in the group of 2. Okay, so here we got 3 and 3 and 7 and 7. There was no space, so I wrote it over here. So 3 and 3 and 7 and 7. If there is any factor left, it is said to not be a prime number. For example, here if 6 would have been left, then this number would have not been a perfect square number. But there is no, what you can say, no factor left, so this is a square, perfect square number. Okay, so let us move behind, and the numbers in a group should be same. Like if 4 is in 4 cannot be, 4 is not a prime number, I'm sorry. If in the first group there is a number 3 and then 3 and then 2 and then 3 again, so I would want to say then the grouping cannot be formed. Even if there are four numbers, okay, the first group is correct, 3 and 3. The numbers in a group are same, but 2 and 3 are not same numbers. And if a group can be formed, which number to take cannot be understood. So this is not a perfect square number, okay? If the means perfect grouping is not correct, the grouping should be correct always. It should have the same numbers. One group should have two same numbers in it. Understood? So this is how to find a perfect square number. So now, what is the next topic? Our next topic is properties of a square number. So square numbers, you can by heart the first 10 or first 15 square numbers because they are very easy to learn. And so yeah, let's continue with the first property. The first property is that no perfect square will end with 2, 3, 7, or 8 at its units place. For example, 22, 43, 27, they all cannot be perfect square numbers as according to the square number property, because they have a 2 at the units place, they have a 3 at the units place, they have 7 at the units place. So they should not have 2, 3, 7, or 8 at the units place. Otherwise, they are said not to be in that we can easily say that they are not perfect square numbers. Okay, so next number also, if other than that, means 1, 4, and 1, 4, 5, 6, 9. If these numbers are there in the units place, you should check. It may be a perfect square, or it may not be a perfect square. So for that you should check. So our next property is, if a number has 1 or 9 at its unit place, then its perfect square ends with 1. For example, you can take 31. If they say you to find the unit number of its perfect square, of 31's perfect square, so what you will have to do is just check the end number. Okay, if the unit number is 9 or 1, then the perfect square will have and will end with 1. Okay, if the number can be if it is 39 or 31, its perfect square will end with 1. But if it is 36 or 34, it will end with a perfect square will end with 4. Okay, so I hope it is clear. So let us move forward. So this is first of second property. The third property is, a number ending in an odd number of zeros is never a perfect square. So this is also an easy property only, but it's a little bit complicated to understand. So here, for example, 6, 4, 0, 0, 0. When you see this number, you know what are odd numbers and you know what are even numbers. One is an odd number, two even number. So like that, you should check the number of zeros at its end. So here it has 3 zeros, and 3 is an odd number. That means it has odd number of zeros at its end. So that means you can easily check that and say that it's not a perfect square number. Understood? So this is also a very easy concept if once cleared. It can also be 50. 50 has one zero at its end. That means it is one is an odd number. So that means it can also not be a perfect square number. So now we know the third property as well, as it was very easy and understandable. So next one is property number 4. This property is, according to me, the most difficult properties of square numbers, because this is a very complicated one. So between the squares of number n and n plus 1, there are two and non-perfect square numbers. So this is a little algebraic type of question. n n means you can take here, n can be 1. Okay, and according to that, the square of 1 is 1 only. Okay, and the square of n plus 1 means 2. The square of 2 is equal to 4. Okay, so you should find the square of that numbers. Okay, so between these two, the square of these two numbers, there are 2 and non-perfect square numbers. That means 1 into 2. 1 into 2 is equal to 2. So here we will check in this formula. 1 by 2 is equal to 1 and 2 by 2 is equal to 4. Okay, and how many numbers are there in between them? 2 and 3. And as I said, 2 and 3 both are non-perfect square numbers. They are not perfect square numbers. Means this is that between n square and n plus 1 square of numbers, there are 2n non-perfect square numbers. So I guess this is a little bit clear to you. To make it more understandable, I will give you one more example. Okay, 1 minute. So here you can take the example of 4 and 5. Get think that n is equal to 4. Okay, 4 plus 1 is equal to 5. That means n plus 1 is equal to 5. 4 square and 5 square is equal to 4 square is equal to 16 and 5 square is equal to 25. Then if 4 is 9, that means 4 into 2. So that means 4 into 2 is equal to 8. There will be 8 two non-perfect square numbers in between them. That will be 8 non-perfect square numbers between them. That are 17, 18, 19, 20, 21, 22, 23, and 24. So this is our fourth property. So it is understandable. And if you count, there are 4, 5, 6, 7, 8. 8 non-perfect square numbers. These all are non-perfect square numbers. So this is a very easy property, but it's a little very complicated one to understand at first. Okay. Once you get to know about it, it will be easier. So our next property is property number 5. This property is a really easy property. That is, the square of an even number is always an even number and the square of an odd number is always an odd number. For example, 28626. So this number has an even number. This is an even number. Am I right? So the square of this number will also be even. So let us take a very easy example, that is 2. 2 is an even number and 3 is an odd number, right? This is an even number and this is an odd number. Okay, so let us check. 2 into 2 is equal to 4 and 3 into 3 is equal to 9. So 4 is also an even number and 9 is also an odd number. So that means the square of an even number is always an even number and the square of an odd number is always an odd number. Understood? So let us continue with the sixth property. A number of a natural number ending with 5 follows a definite pattern. For example, 25, 25, the square of 25 is equal to 2 into 3, 100, plus 25. That means, first of all, you should take this number plus 1. That means 2, and 2 plus 1 is equal to 3. This is 3. And if you multiply them, you will get 5. No, you will get 6. So 600. So this will be the first problem. 600 plus 25 is equal to 625. It's a very easy concept. It would be wrong if you write it as 60025. It will be an extremely wrong one. So you should always write it as 625. Okay. So let me show you one more example for this question. And this is a little complicated one. So you can take the example of the question 35 by 2 is equal to 3, and 3 plus 1, that is equal to 4, into 4, 100 plus 25. 25 will not change, it will remain the same. That is equal to 3 into 4. 3 into 4 is equal to um, 100, and that is equal to 12, and 1200 plus 25 is equal to 1225. Okay, so this is an easy one. So this is property number 6. So let us do the property number 7. So the seventh property is the sum of no, the square of a natural number ending with 5. Oh yeah, the sum of the first and odd number is equal to n. The first, for example, the first two odd numbers is equal to the first. Here you can take the sum. So for this, now what we will have to do is the eighth one is the sum of first and odd numbers is n2. For example, take n is equal to 2. So here it's saying the first of two odd number is equal to 2 square. So first two n number is 1 and 3. First two odd numbers are 1 and 3. 1 and 3, if you add these two numbers, it is equal to 4. That is equal to the square of 2. Understood? So that means the sum of first two n odd numbers is equal to the square of n numbers. So this was an easy property. So let us take the ninth property. That is the last property. Some square numbers are uh, follow an interesting pattern. So here you can say square of square of 1, square of 11, square of 101, square of 1. So this is also a very easy one, and according to me, that is equal to square of 1 is equal to 1. Square of 11 is equal to 1 to 1. Square of 101 is equal to 1 to 3 to 1. And so the sum of four square number 11 is equal to 1, 2, 3, 4, 3, 2, 1. So it's a very easy and interesting one. So that's it. So this is the last one, and I hope you liked today's video. If you're new to our channel, please like, share, and subscribe to our channel. And if you found this interesting, then please like the video, subscribe to our channel, like it, and share with everyone so that you get all of our videos first. So please, with a lot of work, do this completed. Thank you and bye bye. See you in the next